Welcome, everyone, Vitami, to this session. Vitami, that would be plural. Anyway, I skipped my Polish lesson for today. Anyway, welcome to this session entitled Don't Let Your Permissions Be Hijacked. My name is Erland Sommarskog. I come from Stockholm, where I work as an independent consultant, and I've been MVP for SQL Server Data Platform for many years now. If you want to get in touch with me, the way to do that is by old-fashioned email. I don't do any of this stinking social media crap, but this is SQL@sommarskog.se, and you're more than welcome to drop me a line if you have any questions, thoughts, opinions about this session or anything else related to SQL for that matter. I maintain a website, Sommarskog.se, which you can see as a small collection of large articles that goes in depth in a couple of topics. And as a matter of fact, one of these articles, one of the shorter articles, is called Don't Let Your Permissions Be Hijacked. I put up that article about 2 years ago, but I felt that this is something I wanted to create an awareness about, so I also decided to make it into a session. And slides and scripts for this session is available at Sommarskog.se. There are some useful links in that session. I think I also put some of those links in the whole app, but it might be good to get downloads, to get able to get those links. So, yes, sponsors. I mean, if we didn't have these sponsors, first of all, I think there's fewer sponsors this year than it used to be, and fewer exhibitors, and that sort of make the location a little more empty. And also, I mean, without those, this event would either not be possible at all or be even more expensive. So please spend your time with these sponsors so they come back the next year and feel that this is a great thing for them. Now, what is this all about? Permission hijacking. I never heard about that before, you might say. And you might be right, because that's a term I've invented myself. But what it's all about is this. Someone with less permissions than you have, but some kind of elevated permissions, makes you unknowingly run code using, or rather abusing your permissions, doing things that are advantageous to the attacker, and you would never agree to run if you knew that you were running it. And you may ask, how would they do that? And we're going to see that in this session. But before that, I kind of like to get your mindset straight, because there is a risk that you might say to yourself, oh yeah, they could, but wait a minute, no one was going to do that. Just, please, please, please. When it comes to security, there is nothing as too unlikely, too fantastic. If an attack can be performed, it will be attempted sooner or later in some place, and you don't want that place to be your workplace. Because it all depends on the stakes. How desperate is the attacker? What is there to gain? For example, maybe perform advantages update. The classic example is sneaking into the employees table and doubling your salary. But it could be something else. Or stealing data to sell on the darknet, or sell to a competitor, or use when starting up your own business. You never know. Or it could be that attacker is in collusion with some Bitcoin mafia and installing ransomware. Or it's just someone who wants to create a mess. Fred is going to hand down in his resignation just any day now. But before that, he's going to leave a present. And because he's leaving, he doesn't care if he's discovered, really. And he thinks that, oh, the company will not report me because they will put them in a bad light. They want to keep this under covers. Also, I like to point out that not all sites are equal. In some places, things are very simple. There is sysadmin, who takes care of all the database, who takes care of all the servers, and everyone else are plain users who can, run queries and run some procedures and that, and there's nothing in between. Now, these sites are not very susceptible for the attacks I would discuss, but as it says, see below. Elsewhere, it might be more sophisticated. You have sysadmin, and then in some databases there is someone who is trusted to deal with that database, an application admin or a lead developer or database level DBA or something like that, who is in the DB owned role. And then there might be developers who are in the DBDDL admin role, or have at least permission to create some kind of code. Now, these are the places where you need to watch out. That's kind of the main focus. But think about application logins. I mean, it's far too common that ideally, application loggers should run with limited permissions, but it's far too common that they run with some level of elevated permissions. And also, it's far too common that they have SQL injection hole. Which means that someone could come in from that SQL injection hole and abuse those elevated permissions and perform these sorts of attack. Oops, and what about developers whose code get deployed on the server? I will come back towards those at the end. Now, we're going to look at a prime example of doing a permission hijacking attack, the evil DDL trigger. So, I'm going to start with creating a database called AppDB, and I will make SA the owner of AppDB. It's quite common to have SA to own all databases. Actually, I don't think that is very good practice for reasons but not really belonging to this session, but I will come back later to what I think is best practice. But this demo can get a little more interesting with SA as owner. Then I will create a login here for Debbie owner, because she's going to be, well, the database owner. She's going to be, so we're going to add her to app2b, and I'm going to add her to the role DB owner. And then I'm going to play DB owner, but to save some time, I'm not going to open a second window to log in as DB owner. I'm simply going to use this command, execute as login, to impersonate DB owner. So I will be DB owner until I run this command revert, where I revert the impersonation. And Debbie's going to do some perfectly normal work for a database owner. She's going to create one table, and she's going to add some data to it. Nothing strange there. Now, night falls, and it's my duty as a server-level DBA to run database maintenance. So I'm going to run dbcc, I'm going to back up that database, and I'm going to rebuild the index on that one single table. I don't going to do update statistics because when I rebuild the index, I'm going to update the statistics anyway. So I do that. And before we move on, let's see who are the members of sysadmin. Well, the usual suspects, there is SA, there is me, and there are these 3 service accounts, exactly what you can expect. Now, it's time for Debbie to do some more work, and what she's going to do now, she's going to create the evil DDL tree, an auto trig on database. Okay, for DDL, database level events. That is any DDL that occurs in the database. And she checks, if the current user is sysadmin, exec use master, alter server role, sysadmin, add member, Debbie owner. But that's kind of rude, isn't it? Okay. And night falls again, and I'm going to run the database maintenance. I'm going to back up the database. I'm going to run dbcc, and let's check who are the members of DB owner. Sysadmin again. Nothing changed, nothing happened. But now I'm going to run the index rebuild. Oops. And look, Debbie is taking over the server. So this is what happened. She hijacked my permission. I was running this job just to rebuild her index, and she was looking, that DDL trigger, it's sysadmin. I'm going to move to be sysadmin. I'm as well. And if she had been really evil, she might have taken me out of sysadmin. Anyway, so I'm going to take her out. And then I'm going to run the update. I'm going to run the update statistics command. And she's back. So these 2 commands, alter index, update statistics, typically you will have in the database maintenance. They fire DDL triggers, so they could be used by an evil attacker by running some evil code at night. Now let's think about how could we defend ourselves against this. What is really the problem here? Well, we need to be sysadmin to access the database. But once we are in the database, we don't really need those permissions. We only need the database level permissions. So what if we could throw out those server level permissions out the window, at least put them in a little sack, hang them out the window, and then drag them back? Then we would be secure. As it turns out, we can do this in SQL Server very easily. We can do this command, execute as user equals DBO. And you might say to yourself, well, wait a minute, DBO, that's SA, how's that going to change things? Well, we can try it and see what happens. Yep, she did not get added to sysadmin, although I did both the index rebuild and update statistics. So, to understand this, we're going to look at these 2 DMVs, sysuser token and syslogin token. They give us the security tokens that are currently active in the current context. And on a database level, it's very simple. All there is DBO, but DBO is almighty in the database, so that's sufficient. On server level, there are quite a few more tokens because I'm logged in with a Windows login, so that means all my Windows groups are added, but there are also these 2 server roles, SQL server roles, that is, public and sysadmin. And you can also see if you have a usage that's saying grant or deny, except for these 2, which is deny only. Now, what happens if I do execute as user equals DBO? Well, on database level, I also get public and DB owner, but that doesn't really matter because I'm still DBO, the almighty. On server level, well, there's SA, there is public and sysadmin, so I should be able to do everything, except that this one reads deny only. So these tokens are not good for grant, they're only good for deny. And why is this design? Well, when it comes to impersonation, there's a very important principle. what happens in Vegas stays in Vegas. That is, if you do impersonation in one scope, it's only valid inside that scope. It cannot be trusted outside that scope. Because imagine if it was, then Debbie could do execute as user equals DBO, and she would be SA on the entire server. That would be really, really bad. So that's why they have this design. Now you might say to yourself, oh, wait a minute, Debbie could counteract that. She could just sneak in this revert into the DDL trigger. And then it would be back to normal. Well, let's try that. So let's see if that works out. I'm going to create the DDL trigger or change it. And then I'm going to try. Going to impersonate DBO. Going to run the alter index rebuild and up to statistics, revert, and check who has member of sysadmin. No, it did not work. Because revert only acts against and execute as in the same scope. So had there been an execute as in the DDL trigger, revert would have acted against that one, but not revert that is on the outside. That's very important. Now, before I leave this demo, I like to drop this DDL trigger, because after all, it's evil. So the gist of the whole thing is when running index and statistics maintainers, so an application admin or anyone else with permissions to install DDL triggers could do that, adding code checking, is the current user sysadmin, and then do evil things. And adding a user to sysadmin is just one example of what they could do. And maybe not the best thing they could do, because let's say then the next day there is an IT audit, and the auditor says, please show me who are the members of sysadmin. And oh, if Debbie Owner now is all of a sudden listed, she might be in trouble. I have to explain, how did this happen? But they could do something else, like, which is more silent, data theft, manipulations, maybe sneak in some more lower-level login that can still do some backdoor things. You never know. And the line of defense, I discussed what that is, but it has a name, which, again, this time is not my invention. It's called PULP, the principle of least privilege. This is actually, there is a Wikipedia article about it. And also here I have a link to a blog post from Andreas Wolter, who is a security PM in the SQL Server Group, and also a former MVP, who's really great at security. So I recommend reading that blog post about the principle as such. And in this case, we implemented this by doing execute as user equals DBO. Because in this way, what happened was that we sandboxed ourselves into the current database and get rid of all our permissions on server level. So we couldn't be hijacked that way. Now, we have learned what this kind of attack is, and we have also learned the basic lines of defense. But there is a hiccup we need to be aware of that we can run into. So I'm going to restore a database here that comes from another server. It takes a few seconds. And then I'm going to try to move that database and impersonate DBO. But I get this error. Cannot execute as a database principal because the principal DBO does not exist. This type of principal cannot be impersonated, or you do not have permission. Wait a minute, do not have permission. I'm a sysadmin, why can I do this? But the answer to this is, it has to do with the fact that the owner for a database is recorded in two places. In sys databases, there is the owner SID column, but inside the database, for the sys database principals, for the user DBO, there is also a SID. And if we look at this case, we can see that they are not the same. They are different. And why does this happen? Well, when you restore a database, well, if there is already a database with that name on the server, well, the owner recorded in sys databases will be retained. But if it's a new database, you, that is the user running the restore, will be the owner. And in neither of these cases will the SID inside the database be updated, nor will it ever be used as the owner. And of course, using the SID inside the database may not even work, because maybe that is not even a login on this server. Now, the remedy of doing this is when you restore a database, always fix the owner directly. I recommend doing this. And I'm going to do that, and I'm going to do what I think is best practice for a database ownership. A database should be owned by an SQL login that exists only to own this database and does not have any other permissions. And I don't even want to know the passwords. I'm going to give it a GUID that I don't even see, and I'm going to disable it. And why this is best practice, it falls a little bit outside the scope of this session, so I'm just going to, but you're going to see one advantage of this on the next slide, though. Anyway, now when I do this, I don't get this problem. And just this kind of impersonation, for this reason, is just one situation where you can run into this. if you, for example, try to install database diagrams, that's another situation where you will get this error. So it's a very good idea in general to do this. So this slide just repeats what I said in the demos. I will move on and talk a little bit more about running database maintenance as such, because we now know what the errors are, and we know the defense line of defense. But of course, we are not doing this manually, nor are we, I hope, not writing our own scripts, but we're using one of the two standard solutions which are out there. So one very popular is Ola Halligan's maintenance solution. Anyone in the room? Yeah, good. I see a few. I'd hope there would be more hands. But anyway, if you're using his solution, you're in very, very good position, because Index Optimize accepts the parameter at execute as user, which you can set to DBO or any other user of your choice. So he has it all solved for you. He takes care of this problem. Really great. The other solution, which is also common because it's the default, kind of default, it's the maintenance plans in Management Studio. Bad news, they don't have support for execute as user because when they designed those, no one thought about this problem. So if you are using these and you're insisting on using them, what can you do? And you have these kind of servers. Well, one is just to say, okay, I'm going to do backup in DBCC and tell the users you have to do index and statistics maintenance yourself. But if you still want to do that, well, you can still do that, but then you will have to set up a task for every database and define the login for each database, and which has to be a login, which is DB owner in that database. And if you set up database ownership, as I suggested on the previous slide, yes, that is, you have that login. But it's a little more work, or you can switch to a solution and be done with it. Now, so far we talked about database maintenance, but when you think about it, of course, any DDL you run as a DBA is dangerous. I mean, you're creating indexes, you're creating users, granting permissions, certificates, whatever you do in that database, you must bracket with execute as user equals DBO. And when you have in that database, you know that there is someone who's DB owner who has permissions to deal with DDL triggers. I mean, okay, that's, as I said in the beginning, quite a few servers, there are no such users, and then you can relax. Now, but if you have that situation, you must do this. And a corollary of this is, no, you can't use that UA Management Studio directly. You must use the SQL commands. And then some people might, well, wait, you get very nervous. Okay, you can use that UI if you own, just as long as you stay away from this OK button down here, because you can use this script button on top to get the commands, and then you can create them and then bracket them and execute as user equals DBL. Now, so far about DDL. Moving one step or two ahead. So far, attacks against sysadmin, but that's not the only principle that can be under attack. So, Debbie, she gets an assistant here called DevDave. He's going to help her with working with the application. So, he's going to be added to the DBDDL admin role. And because he's writing stored procedures all over the database, he needs to run them so he can test them, so he gets permission to run all these procedures. And because he can write procedures all over the database, he can write procedures that inserts to any table without no further checks, because everything's owned by DBO. So he's going to give him permissions to full permissions on all tables, because he basically has that already. So I'm going to play DevDave, and he's going to, do some normal work. He's going to create a table, create a procedure for that single table. Nothing strange there. And let's look who are the members of DBO now. And we have a DBO, we have a DB owner, and we have also DB owner. Now let's see what DevDave is up to now. He's going to create a DDL trigger. Now he's not supposed to work with application, but he can create DDL triggers. Okay, for all DDL database level events, so that's any DDL. Okay, and the same thing as Debbie. If sysadmin runs this, he wants to be a sysadmin, okay? Strange kind of people we have in this database. But if that is not sufficient, because at least if Debbie runs this, if anyone is DB owner, he wants to be at least as cool as Debbie, so he can do more things in the database. Yeah. So he's adding that DDL trigger. And yes, he could do that, because, he has that permission, thanks to being a member of DDL admin. And then, Debbie's going to do some normal work. She creates a second table. And look here. DevDave hijacked her permissions and is now a member of the DB owner row, and now can do, things in the database he was not supposed to do. He's not entrusted to. Well, so how can Debbie defend herself against this? Now, this is a kind of a little special case because when we think of it, as I already alluded to before, should Dave really be able to do this? As I said, he's supposed to work with the application. But are DDL triggers part of the application? Not in my opinion. That would be a very contrived case in my opinion. Now, DDL triggers, they might be good for auditing. I mean, Debbie might want to have DDL triggers to see what Dave is actually doing. So, this is what you're going to do. First of all, she's going to review, what DDL triggers do we have? Okay, we don't want that one, so she's dropping that DDL trigger. And then she's going to fix and take Dev out of DB owner. He's out, good. And next step, he's going to take him out of DDL admin as well. And she's creating a new role, our DDL admin. And she's making that role a member of DDL admin. But now for the important step. Deny alter any database DDL trigger to our DDL admin. So this role can do anything that DDL admin can do except for creating DDL triggers. And then she's adding Dev to that role. And before reverting back to myself, I'm going to just final check. No, Dev is not part of that role anymore. So he's going to have some drink. So, and now, just to prove that things are working, I'm going to impersonate Dev, and he creates a table and he creates a procedure, and he can still do that. But then it discovers, wait a minute, where is my DDL trigger? Okay, it's gone, I'm going to recreate it, he says. Nope, cannot create the DDL trigger, Dave's DDL tree, because you do not have permissions. So this slide basically repeats what I said in the demo, except for that I'm also mentioning the possibility that rather than having a role, you could also ask for an AD group that you add to DDL admin if you prefer. And you may ask, so why did I not just simply deny DDL admin this permission? Because I cannot do that. SQL Server does not agree to doing denial of built-in roles. So I had to create the extra role. Now, before I move on, I'd like to discuss some of these commands a little bit more in detail because I will come back to that. So the execute as commands, there are two of them. There's execute as user, which means that you run commands as a database user. You're doing impersonation on a database level. And when you do this, you're sandboxed into the current database. You cannot access other databases. Well, you can actually access TempDB and master because they have the guest user enabled. And to do this, you need impersonate permission on the user. But of course, if you're a member of DB owner, you have this permission. Then there is execute a login, which means that you're running commands as a server login. So you're doing impersonation on server level. And in this case, there is no sandboxing inside SQL Server, and you need impersonate permission on that login. And that's a server level permission. And of course, if you're a sysadmin, you're a member of that permission. And of course, if you're only going to do this, because both of these are great for testing permissions. So if you, for example, you're setting up a database role, your database, and you want to see that, okay, this role should be able to do this and this and this, but not do that and that and that, you can create a user without login and to that group and impersonate it and play around. And you don't have to create a login, go to do that because you create a user without login. Or the same thing you're going to do on server level. If you're going to test another user and it has a login and you have the permissions, it's better to use execute as login because you don't have the restrictions inside the database. And in this particular case, execute as user is really great for throwing or at least hanging out our server level permissions out the window temporarily. The revert command, as I mentioned, is in force until, the impersonation is in force until you execute the revert command in the same scope. But if you have it if it's executed in a nested procedure, it does not have any effect at all, unless there is impersonation inside that procedure. And important to know is that you must execute the revert command from the same database where you started. So if you impersonate the login, you are in database A, and then you move on over to, well, database X, and then you do revert. Now you will get error message. You need to get back to A. And here's a tip about revert. Always put it on a batch of its own. There is no syntactic requirement to do this, but if you have it, let's say execute as some statements and revert all in one batch, you run this and this error is out, and maybe then the batch is aborted and revert is not executed, but in your mind it has been executed, so you play around and then you start to get errors and you don't understand what's going on. I know, I've been there, done that more than once. Yes, I learned this the hard way. And if you run too many reverts, no problem, you will never get an error of running one revert too many. And there are some variations how we can do impersonation. For example, you can say execute as with no revert. So, and why you do this, I will come back to this later on towards the end of the session. A linked service, these can cause some problems when we're playing around with impersonation. First of all, if we do execute as user, we don't have access to linked servers at all because they are server objects, so we can't even see them. Now, when we set up a linked server, there's two choices for authentication. First of all, there's self-mapping, which means that if users are accessing the linked servers, they're using their own credentials. This is good for security because they cannot really gain with getting to the server, to that remote server by going through this server than they can do when logging into that server directly. But you can also set up login mapping so the login is done with the username password pre-stored in SQL Server, and that must be an SQL login. It can neither be a Windows login. And you set up this mapping either for user or for everyone. So, for example, everyone might be using self-mapping except for that account or vice versa. Now, the important thing here is that if you do execute as login, self-mapping does not work because what happens in Vegas stays in Vegas. It's only valid inside that SQL Server instance. It's not valid in Windows. It's not valid on that other instance. If you have login mapping, that's still going to work because there's no impersonation going on to the remote server. But this can give us some grief when we are using impersonation to avoid permission hijacking. Now, so far, I talked about the attacks through DDL. But when you think of it, of course, we can also do this with help of DML triggers or stored procedures. So let's say you're doing data maintenance as a DBA owner or a sysadmin in the database, and whatever for reason, and you do that daily. And are you going to check if there happens to be a trigger all of a sudden that does something evil? No, probably not. Or you're running some stored procedures, maybe part of the application, or some maintenance things. And down on the fourth nesting level, all of a sudden, Dave has managed to sneak in something that does something evil. Not likely. Now, if it's all a matter of protecting the sysadmin, we already know how to protect ourselves. And we only need to protect sysadmin because there is no one between DB owner and the plain users. Well, impersonate DBO, execute as user equals DBO. And we might even prefer to keep a window open where we have this. And it might, however, be the case that for operation, we need to get data from outside the database. Well, we can do that by reading it. So we can read that data into temp tables before we do the impersonation, because even if we have done impersonation, we can still access those temp tables. So that's a solution around that problem. But how to protect DB owner? That is, Debbie needs to protect herself against DevDave when she's doing, data maintenance or running the procedures. Well, we have to think again about POP, principle of least privilege. If she's going to do data maintenance, runs the procedures, does she need her almighty powers to create users, certificates, all that? No, she does not. So the way she could do is to create a sandbox user with limited permissions. So here's an example of how she could do this. First of all, she says, create sandbox user without login. I mentioned this previously, but I do it again. Yes, you can do this. This is a kind of an orphaned user, which is orphaned by design. And it's a really great feature for testing permissions. And in this case, because, Debbie does not even have the permissions to create login. And she gives some suitable set of permissions. I'll come back to that on the next slide. And then impersonate that one. And she can play that when doing the data maintenance and that kind of stuff. Now, so in many cases, to keep things simple, you can say that, okay, that sandbox user can run any procedure in the database and can update full rights on permissions on all tables. And particularly, in the case of someone like DevDave, that's enough because DevDave already has these permissions. So why should he hijack Debbie's permissions to do updates? Yeah, maybe to do some sneak around auditing, I don't know. But let's skip that for a while. But imagine that in the database, there is also Betty Business Analyst. And she has let's say she has read permission on all the tables, but she only has write permissions to her own schema where she can create tables and do her things. And then one day Betty asks Debbie for help to deal with her tables because, you're better at SQL than me, Betty says. But it turns out she had installed some nasty triggers on her tables that goes and all of a sudden does things in the other tables and doubles the salary or whatever. In that case, Debbie may need to create a sandbox user that only has permissions to Betty's schema to make sure that nothing happens. Against the principle of least privilege, but we have to apply these the pulp with some kind of pragmatics. Now, let's say this, you are a sysadmin and you're being asked to do some, well, data maintenance, data cleanup stuff in some database, which you normally do not work in because the people in the database manage themselves. But please, Mr. DBA, you're really good at SQL, so we need some advanced help here. Okay, I can do this, but do you have a sandbox user I can use? And you only get a blank stare back. What, a sandbox user? But you feel that you don't want to be in something bad happens. You don't want to get the blame. So the way you would do it to play it safe is, first of all, get in the data you need from outside sources into temp tables. Then you impersonate DBO with the execute as user. You create a sandbox user without login and grant them a reasonable set of permissions. Impersonate that sandbox user, do your task, revert back to DBO, drop the sandbox user because you're only making a guest appearance, so you don't want to leave anything behind, and revert back to your true self. So the key here is you need to do impersonation in 2 levels, yes, and you can do this, but you need to do this because if you create the sandbox user directly, well, then you could be hijacked by the DB owner. Now, things might be a little more complicated because what if the task requires access outside the database? And with execute as user, we are sandboxed into the current database. It could be, for example, we have some procedures like do cross-database access. Or these, well, as said, we could get data into temp tables, but maybe those tables are very big and we don't exactly know what rows we need, so we need some join conditions. It's just getting impractical. So what do we do in that case? Well, we need a sandbox, a login, so we are rather than a sandbox user, so we can have limited permissions in more than one database. And then we can do that and impersonate it, or because it's a login, we can actually go and log in as it in a separate window if we prefer to do that. And if we are sysadmin, it's very simple to do that because we have all the powers. Debbie, or anyone else who's only in the DBA own role, she would have to ask the server DBA to create one and then get impersonate rights on that login or get the password. But I would say impersonate is really better because then there is no passwords drifting around somewhere. Now, and getting back to the previous example of playing the sandbox login, so you would create the sandbox login. Again, the task is here again, you're going to do data maintenance, but involves more than one database. So in all the databases you need to access, you're going to impersonate DBO, create the database user for the sandbox login and grant permissions, revert, yes, and then impersonate the sandbox login with execute as login or, well, log in as it if you prefer to do that. Perform your task, and then revert back to yourself. And in all databases, again, impersonate DBO, drop the database user and revert and drop the login. Well, you might say to yourself, that's kind of a little more of a bit of work here. Can I just have some of this canned? And of course, yes, rather than creating that login every time, you can have it around if you'd like, if you're going to do that often. But when it comes, and disable it, then if it's only going to use it for impersonation. But if there are many databases on the server, be a little careful of leaving that database user around. But rather, you should drop them when you're done. Because else imagine this, you're doing work in database A and B, but you also have that sandbox login as a user in database C. Well, the evil people in A and B could hijack that login and do things in C, which they should not be able to do. Again, the principle of least privilege. Now, things might be even more complicated. We might have access to linked servers. That's actually quite common that we run into this. And in this case, if login mapping is if a linked server is set up with login mapping, impersonating a sandbox login will still work. But if there is self-mapping, yeah, it starts to get a little complicated. So one solution is to set up login mapping only for the sandbox login. But this requires that remote service is enabled for SQL authentication. And if it isn't, it has to be restarted. Or else you could have an AD admin to create a Windows user that you want to use a sandbox login. And then you can start Management Studio with the runners command to run in asset. You don't have to log in into Windows entirely. But that, yes, as I said, that's a little complicated, but I will leave you there and start to instead move on and talk about application users. So an application may log in users with integrated security, so the users are themselves in the database, or log in with its own login and password. And the latter is very, very common for web applications. In either case, ideally, these users or application login should only have permissions to run the procedures. And these procedures should perform permission checks. But yes, that's the ideal. But we all know that far from all applications are using the procedures, or if they are, they're not using it exclusively. So we may have no choice to grant and delete select permissions, and in many cases also insert, update, and delete. But this is where you stop. You should never agree to add more permissions. And why? Well, Because if there is an SQL injection hole, and yeah, if there is an application, we can almost assume that there is an SQL injection hole. I'm that cynical. I mean, yeah. So, I mean, even with these permissions, you can create some damage because you might go delete important data you should not be able to delete or update, but at least it's confined to that particular database. It cannot spread to the rest of the servers. It cannot spread to the rest of all the other servers in the system. And by the way, if you have that kind of application login, well, of course, that can be a sandbox user that you can use as well. Now, what if the application still needs to do things that requires permissions beyond this? Well, there is a solution. So for this, that I'd like to discuss briefly. But as an example here, let's say we want to show a count of users connected to the database. And to do this, we need permissions to the access to the DMV sys DMX accessions. And if you don't have that server level permission, you will only see your own session. But with that permission, you've got access to all DMVs and lots of stuff. So we don't want to give that to the application login. Now, what if we could put that grant that to a stub procedure instead, and we could put the code needed for the count into that stub procedure? We have full control over how the permission is employed. What if we could do that? And we can in a little bit roundabout way. So we have to sign the procedure with a certificate, and then from the certificate this certificate creates a database user or a server login, depending on if it's a database or server level permission, and then grant that user or login created from the certificate the permissions required. That's the very short story. That's a fairly elaborate technique, and certainly don't have the time to talk about that today. But on my website, there is an article called Packaging Permissions in Stub Procedures, and includes stub procedures and script to automate the process. The article is fairly long because not only do I explain the mechanics, because I also explain how it works. Because I think using an advanced security feature without really understanding how it works is not really secure, because then you might be using it in the wrong way. And also, anyway, there's also recording on YouTube, because I also have a session about this. As a matter of fact, I think I did this session at SQL Day here like maybe 6 years ago. But this is a recording from another event, an online event. And the link, if you download the deck, you will get that. I think that link may also be in the whole app. I don't remember. Anyway, here I'm only going to discuss some key facts when using this technique. So when you change this assigned procedure, the signature will disappear, and thereby also the permissions. So it must be signed again. So imagine this. Debbie comes up to me with a procedure that shows the user count. I look at it and says, yeah, this is good. So I review it, I sign the procedure, I arrange all that with a certificate, grant the permissions, and Debbie is happy it runs. But then Debbie thinks, nah, I want to be able to do this as well. And she changes it, but it finds that it doesn't work anymore. So she comes back to me and says, wait a minute, can you sign it again? And I look at the code and says, no, Debbie, no, that, never going to agree with that. Restore the old version, I'm going to sign it again, but not that, that's not okay. So I'm in full control. She can't use this to do things behind my back. And in the context of permission hijacking, here's a very interesting behavior. So if, let's say, you have a stub procedure and you sign it and you're doing some dynamic SQL, those package permissions will apply there as well. So let's say that you only want to grant execute permissions to the application login, but you still want to do dynamic SQL in the stub procedures. Then you can sign the procedure and package select statements with it, and that will work out. And if you're calling system procedures, well, permissions will apply on that side, those as well. But if you call the user written code, you fire a trigger, or you call a function. No, now the permissions are removed. They are not active in that submodule, which means that they cannot be subject to hijacking. So if Debbie gives you procedure, you see, it calls that procedure, insert to that table. You don't have to worry. No hijacking can happen. Well, you need to watch out for dynamic SQL, because probably dynamic SQL is built from something like an input parameter, some row in a table, or even a table name. Now, nasty things can happen because you don't have full control. Now, let's move over and talk about agents' jobs. So Dave comes up to you and say, oh, Mr. DBA, we need to run purge in our database at night. Could you schedule an agent job that runs this like 2 o'clock in the morning? And what Dev is now hoping is that you will go on autopilot and just create a sysadmin. And if you do that, yeah, Debbie and Dave is now going to do high five and says, hey, we're taking over the server, because now they can change that procedure that will run a sysadmin. But of course, you're a lot smarter than that. You're going to lean over to Dave and say, now, Dave, why don't you run that from Task Manager on the application server? I mean, between you and me, I mean, agents is for maintenance tasks. It's not really for application jobs, is it? Okay, we may not always win that battle, that's true. So we have to look for some alternatives. Before we do that, however, I like to establish some principles. First of all, job owners should be not be persons that can leave the company. It should always be some kind of abstract owner. I think no one disagrees about that. And also, I'd like to say this, don't add users to MSDB because it's a kind of a creepy place. You don't really know what's going to happen. They might get one small permission. All of a sudden, oh, they can do this as well. So keep them out. That's the simple part. And from this follows that setting up an agent job is always the sysadmin task. Not writing the procedure, I mean writing the code, that's Dave's task, but defining the job itself. But also I think this application jobs in agent should be executed with the same permissions as application users because it's part of the application. So why, because it runs through agent, why would it be different? If the job would happen to need elevated permissions, for example, let's say we have a petition table and at the end of the month we need to create a new petition, well, sign procedures. That's the technique to use here as well. Now, so what alternatives do we have to Dave's purge job? So one is to, on the job step, we can, on the advanced tab, we have this one, run as user, for example, app login. And if we do this, agent is going to impersonate the user, will execute as user, which means that we are sandboxed into the database, no cross-database access, no link server. But if it's only a purge job and not an archiving to another archive database, that should work in this particular example. And important to note, the job must be owned by a sysadmin. If it's owned by someone else, that setting is ignored. Then we have the other alternative, or the next alternative, is to set the job owner. We do on the front page. And again, we're going to pick someone who has application permissions. And that could be an SQL login, or it could be a Windows login. Whatever we like, but it has to be should be application permissions. In this case, agent is going to do impersonation with execute as login instead, which means that there's no restriction with cross-database access. So for that, if that is an archive job on the same database on the same, on the database on the same server, no problem. But if we have login mappers with login mapping, they will work, but not those with self-mapping. They will still not work. And there is a nasty side effect if you do this, because this job owner will be added as a user to MSDB and a member of the SQL agent user role. Not directly. It will happen next time you install a cumulative update or a GDR, because they always run a script where they do this. Yes, and I tested this, well, not with the latest CU for SQL 2022, but at least CU1. And this has been around for a long time, this madness. And then the last alternative is a little more complicated, but it's actually my favorite. It's in more steps and involves more people, but the advantage is here, there is no impersonation because there's a real login into Windows, so there's no restrictions with linked servers. And so we first have to get an AD account, and then we've gotten that AD account from the AD people, we're going to create a login in SQL Server, and if there are linked servers involved, we have to create on every server. And then we have to create database users and grant application permissions. And if we have an applications user role already, well, we're going to add that user to the application users role. And then we have to create a credential for this account. So we say credential, we give it the name with identity, and that's the name of the Windows user we got from the AD people, and with secret, that's the password. And typically the name of the credential will be the same as the Windows login to make our life simpler. Then in agent, we're going to create a proxy. So, and when you open the node in agent, there is a couple of nodes, and one of these called proxies. And then you can create a subsystem, and then you will have to specify credentials. So that will be the credential you specified in the previous step. And then you have to give the proxy name, and again, you will typically use the same name to make your life easier. You don't have to, but I would say you would do that. And then you create a job with an agent with the sysadmin as the owner, and you will create the job step, and you do that in this way. So the type of the job will be a command exit job, not a TSQL job step. And then in the runners dropdown, which is empty for a TSQL job step, you can specify, you will select the Apple job runner. And then what's going to happen now is that, okay, SQL Server will see, okay, so there's a proxy, yes, there is a credential, and then agent will retrieve the username and the password for that credential and log in as that credential, and then run the command you have specified here. And typically there will be a call to SQL command, that should look something like this. So -I, that is just a turning on quote identifier, because by default, agent runs with quote identifier off, and then -B to propagate the error code. So if something goes wrong when you run the command, of course you want the job to report it as failed, and for that end you need -B. And then this mumbo jumbo after S is for specifying the server, and the reason to do this, it's an agent token, is that then you can easily move the job to another instance, and you don't have to bother about changing the server name. And finally, you specify the database and the command to run. Typically, it's to procedure. Now, as I said, we wanted to keep users out of MSDB, so they can't see the agent history of application admins and developers. So you will have to set up mail notifications so they get a mail if the job fails, or also on success if they prefer that. And then on the advanced page of the job step, you can define an output file, which you cannot do if the job owner is not sysadmin. So that's another nail in the coffin for that option. And then you direct the output to a share where the application team has access. So if something goes wrong, you don't have to be involved. You only set up the job, and then the application team can manage that. Now let's talk about another forms of attack, attacks through deployments. So far, the attacker has always been someone who's authenticated, who's already had access to the server, either directly as a user or coming in through an SQL injection hole. But let's say this, you get a deployment package from the application team. And when you think of it, it could include all sorts of nasty stuff. They add an extra logins to users with elevated permissions. They manipulate data in any database on the instance. I mean, that deployment package is big. You don't have the time to review all of it. Or they could even do this. Because the interesting thing is not on this instance, but you know that your system and your DBA, you also have access to that system B. So they set up a linked server using self-mapping, go in and whoops, snatch that data, and then they don't have access to this system, but you set up a linked server to a test service C, where they do have access, and whoops, and they have the data. Yeah, kind of an evil thing, could happen. And how do you protect yourself? Well, let's say for simplicity's sake, we get a script. Well, again, we can do this execute as user DBO, but we need this extra step with no revert. This means, because now we're running a script, so they can inject revert in that script. But with no revert, we're outlawing that. So any revert will cause an error. And if you get that error, it's time to call the police, because now something is going on. So that's the point of using with no revert. Although, if you do it this way, what you are essentially doing is saying, okay, the application team are for all practical matters DB owner. They don't have access to the server. But as I said, you can't really control what's going on there. But if you say that, no, they should only deploy code, store procedures, triggers, etc. They should not create users or anything like that. Well, then, of course, use a sandbox user in our DDL admin role to restrict that. Or let's say that could be even more restrictive. Let's say, for example, it's a vendor application where you're only permitted to do things by the vendor in a certain schema. Of course, the sandbox user should only have access to that schema. And they might also do things outside the database that might be expected. Well, then they can use a sandbox login instead, but it's still set up with the set of permissions you're prepared to give the application team inside the database. And on server level, you will have to assume that they don't do too much. Now, and I will recommend that you first run this in QA, because they might tell you, no, we're only doing this, and then you run it in QA, you get all sorts of errors because, we do this. And those actions might be perfectly legit, but you at least want to have that in control so you don't get a mess in production. But running in QA may not, however, not reveal the malicious actions, because they might check the available permissions, or they might even check the server name. But things could be a little more complicated, because let's say they're doing legit actions on a very high level. So, because if they're doing simple things on server level, you might, okay, give the sandbox login that permission, that's okay. But they might even do things that require sysadmin, because let's say that this service is dedicated to this one application, that they realize, okay, we want to turn this on this configuration option on. And that's perfectly okay. And you can say, well, please give me that in a separate script. But it could be that is a vendor application, or everything's put into a DAC pack or MSI install, and you don't really have control. And worst of all, it's supposed to be running with integrated security. So how are you going to deal with this now? Well, I guess auditing is your only choice. And then I'm talking about server level, because still assuming that on server level, not too many things are happening. And that is nothing I wanted to dive into, but the one thing I like to discuss, though, is that there's more than one way to do auditing. But SQL Server Audit might be the only one that audits that has been turned off. Because that's important. Because, of course, if they are doing evil things, they're going to turn off any auditing. And particularly when it comes to DDL triggers, you might set up server-level DDL triggers, but a DDL trigger can be disabled with disable trigger, which does not fire any DDL trigger itself. Finally, attacks through applications. So you're running the time reporting system or some other, well, purchase approval or whatever, normal application. But it turns out that the developer of that application says, oh, Mr. DBA is running this. Okay, I'm going to go into the HR system and going to do something here using his credentials. And you can't really protect yourself against this because you're only running that application, so you can sneak in, execute as, etc. But what the IT department in general can do, though, and I have actually experienced this at a bank where I did some guest appearance. So I had a one Windows login for the normal company work. I logged in into Windows, and when accessing the sensitive servers, I had another login, which I connected through remote desktop. So I guess that account was only good for doing that stuff, but I couldn't do like time reporting or anything like that with that account. And of course, you could also question, should really the application server for the time reporting system really be able over the network to access the sensitive SQL servers? Probably not. Also something for the IT department to look into. So, what has this session been about? Well, as I said in the beginning, malicious users with some set of elevated permissions can inject code that you unknowingly execute with your permissions, performing actions you don't agree to. And elevated permissions here includes access to the deployment pipeline. Yeah, contiguous integration is great. You go and change the code and 30 minutes later it's in production. Yep, really good for permission hijacking if you don't watch out. So, we talked about some number of lines of defense, and it's all based on the principle of least privilege, POLP. So, impersonate DBO to get rid of your server level permissions, to protect DB owner from being hijacked using sandbox users or logins. Never put people directly into DDL admin. That's just, I think that role is incorrectly designed. But create a role, our DDL admin, or whatever you like to call it, which you deny the rights to DDL triggers. Application users should have limited permissions. At most, select, insert, update, and delete on tables. And application tasks and agents should run with application permissions, never elevated permissions. And when we need in the applications elevated permissions, procedure signing, as I refer you to, it's a quite long article, but then again, to do this on database level, you don't need to read the full article, about only half of it. But anyway, it's a really great feature to deal with that. And again, the application team may in practice be equal to DB owner, even if they don't have access to the server, because reviewing a full deployment package for database, if you're a DBA on many servers, you will never have that time. Some final words. Yes, some of the attacks I've suggested may seem very contrived. But again, as I said in the beginning, if the stakes are high enough, a possible attack will be attempted sooner or later. Now, in the beginning, I mentioned a number of reasons why people would do this out of malicious intent. But there's one kind of attacker I did not left out, but I like to discuss. And that is the benevolent attacker. That is not an attacker that has malicious intent. It's only someone who wants to get solution for the business user. And for example, I mentioned the application team may sneak in extra logins in that deployment package. And that may not be out of evil intent, but they may just be sick and tired. Every time there's an issue in the application, they just being sick and tired to have asked you to run a script, to get execution plans, etc. And they say, let's be done with it and just install this login and stop this stupid theater. We should have access to the server, period. And of course, that's the wrong way to do it. They should do that, the organizational way, go there, talk with their boss, let's talk with your boss, etc., etc. But yeah, I was at Sessions Pass a couple of years back, where the presenter, he was talking about things in Agent. And he had done exactly those kind of things, exactly to deliver solutions to his business users. And yes, you could have made those users sysadmin. I mean, if you'd done that, you would not have these permissions, but you decided to lock down their permissions. And it's certainly not a bad idea in itself to lock down permissions. But if you do this and you don't watch out, people might find a way to work around that restriction. So, yeah, I'd like to again thank you, the sponsors for this event. to making this event possible, or at least more affordable. Thank you very much. So, my name is Erland Sommarskog. My email address is sql@sommarskog.se. You find slides and scripts for this session at sommarskog.se/present. Here's the full link to the article. I've covered most of it, but there are some more kind of, maybe even more contrived text that could appear. If you're running the demos, here's a cleanup script that you can run. And I did not get that on, but please submit in the Yahoo app, submit your feedback for the session. And we have a few more questions, a few more minutes for questions, opinions, thoughts. You're more than welcome. Or do you think this is just too radical? No one would ever do this. Anything online? No? Well, thank you very much for listening and enjoy the rest of the conference.